So for this video, I'm going to show you how to convert a rectangular ordered pair to an ordered pair in polar coordinates. Our final answer is going to have r greater than 0 and theta between 0 and 2 pi. I'm also going to show you how to find some of the other answers as well, other representations as well. So first of all, I'm going to draw this picture. So this is an xy ordered pair. I'm looking for an r theta. So -3 root 3, that for an x value means I'm moving left. And then -3 for a y value, that is -3. For a y value means that I am going to move down. So that point is somewhere down here in the third quadrant. It's not, it doesn't matter, we don't need to be super precise there. So this is that xy ordered pair, -3 root 3, -3. That's this ordered pair. What I'm trying to do is to find this length r and this angle theta, and that's going to give me the polar ordered pair. So how I'm going to do that is to use the relationships that we know between rectangular and polar coordinates. The first one is that x squared plus y squared equals r squared. This is going to help us find r, and then in a minute we'll use that tangent of theta is equal to y over x to find what theta is. So x squared plus y squared equals r squared. My x value is -3 root 3 squared. My y value is -3. We're going to square that. And that's going to give us r squared. -3 squared is 9. Root 3 squared is 3. -3 squared again is 9. This is equal to r squared. 9 times 3 is 27. 27 and 9 is 36. So this is r squared. So r is plus or minus 6. Our directions tell us to use the positive r, so that's what we will do eventually. Now moving over here to tangent of theta is y over x. So tan theta is equal to -3 over -3 root 3. Those -3's are going to cancel, so we actually have that the tangent of theta is equal to 1 over root 3. And you can think about this as 1/2 over root 3 over 2, and then think about the unit circle angles, because this is sine of theta over cosine. So where is sine small and cosine big? So sine's small at pi over 6. Right, think about that. This triangle here, the 30-degree one, the sine value is small, the cosine value is big, so that's the correct angle. And where else is tangent that value? Well, at the same place down here in quadrant 3 at 7 pi over 6. So these are our options. We have plus or minus 6, and then pi over 6 and 7 pi over 6. If you jump to 6 and pi over 6, look for me where 6 pi over 6 is. Think about that. That would be 6 pi over 6. That would be right here. Is that where we're trying to be? Remember, this is what we're going for. Are we trying to be in quadrant 1? No. So that's not the right thing to choose. So suppose I choose +6. Let me not do that in yellow. Say we choose +6. We want to rotate all the way down here in quadrant 3. Well, this angle will do that. So 7 pi over 6 is actually what we're looking for here. Now, if I wanted to use pi over 6, I could use -6 as the radius. Go out -6, rotate down pi over 6, and there you have it. You could also use +6. Let's do this in red. Use +6 and then rotate down, but you're short a rotation of pi, so this would be -5 pi over 6. Or you could do -6, rotate out, go out this way negative, and then rotate negatively all the way around. You're short a full rotation by 1 pi over 6, so that would be 11 pi over 6. So there are 1, 2, 3, 4 ways to do this, ways to represent that on just one rotation of the unit circle. But this is the answer that we are looking for, 6, 7, 5, or 6, because we were told to have r greater than 0 and theta between 0 and 2 pi.